Now that we've gone over all of what makes up the runner, I'll kick off a scenario created with Talonx's GNSS simulator, BroadSim, and see how PANACEA field test works in action. The scenario has our receivers follow a path across the Arlington Bridge, loop around the roundabout directly across from the bridge, come back over the bridge, loop around another road, and come to a halt near the starting location. I've placed a jammer in the middle of the roundabout directly across from the bridge. Let's see how this jammer affects the units under test, as well as characterize the threat from our spectrum. Afterwards, we'll take a peek at Panorama, a data analysis tool created by Talonx that streamlines the post-processing of test data. Now that the simulation has begun, our receivers will start making the trek across the bridge. As we can see now, our units under test are reporting a carrier-to-noise ratio in the 40s, using 10 SVs to navigate, and have a position error under 15 meters. What we want to look out for is the emergence of the jamming waveform in our spectrum and the degradation of the receiver's ability to navigate as we cross the bridge. As we continue getting closer to the jammer, we see the waveform emerging in our spectrum. It looks like an AWGN waveform with roughly 1 MHz of bandwidth. We can see our carrier-to-noise ratio dropping steadily the closer we get. When we get close enough, the number of SVs that we are tracking will also fall. When this number falls below 4, we will start to see the receivers drift around on the map as they no longer have a 3D navigation solution. This is a good time to log a field event. It will give us a timestamp in our log files and an overlay in our panorama plots. This makes it easy to pinpoint the time, position, and channel power where we could no longer navigate due to the jammer we observed. The receivers will continue to drift until the simulation gets far enough away from the jammer for our units under test to regain 3D navigation. Now that we are sufficiently far enough away from the jammer, our receivers have regained 3D navigation, our number of SVs has gone back up to 10, and we have a position error back under 15 meters. We can log another field event to indicate that we are no longer seeing the effects from the jammer. Now that the scenario has come to a conclusion, we can use Panorama to take a look at some of the plots from this test. Since we are done collecting data, we can go ahead and stop the test. Now, with our Panorama application open, we can click on the Panorama icon near the Start/Stop button to pull up the test. Here we have the test pulled up in Panorama. I'm currently looking at the number of SVs used plot in the Scenario Plots tab, which lets you look at all receivers you had connected during the test overlaid on each of the plots. On this plot, our blue and green lines are our 2 units under test. The black line across the bottom is our channel power taken from the signal hound, and the 2 vertical black lines on the plot are the 2 field events that we logged. As we can see for both of the receivers, the number of SVs they used dropped rapidly as they approached the AWGN jammer. They went from a value of 10 to 0 in under 10 seconds. If we look at our channel power at that time, it looks to be roughly negative 72 dBm. If we want to take a closer look at that, we can open up our spectrum viewer to see the exact spectrum at that time. We can see our AWGN jammer here, roughly 1 MHz wide, and our channel power reading almost negative 72 dBm, which is a 38 dB jamming to signal ratio. As the scenario time rolls along and the channel power starts gradually dropping, we can see an inverse relationship in the number of SVs our receivers are using, until we reach the safe point marked by our second field event. Let's take a look at another plot. Here's the position error that was recorded during the test. We can see that both of our receivers jumped their position error quite rapidly once the channel power was raised. One of our units under test drifted almost 3 kilometers, but corrected itself very quickly down to 10 meters of accuracy once the channel power was lowered. Our other receiver only drifted up to around 300 meters, but corrected itself very gradually until the end of the test, where it had finally gotten back down to 10 meters of accuracy. These are only a couple of the plots provided in Panorama that help give engineers insight into what's happening in the environment and how their equipment is responding. That brings our tutorial video on PANACEA field tests to an end. Thank you for watching, and be sure to visit us at www.talon-x.com to learn more about our products, offerings, and how to contact us.